Hello everyone, my name is Surendra Ambati. I've been working with CRISIL for past 9 years. I specialized in credit risk, market risk, and different programming languages such as C++, Python, and SAS. Currently, I'm working in the field of the data engineering. I'm recording this video to show you a tool I developed for SACCR. SACCR stands for Standard Approach for Counterparty Credit Risk. This is my LinkedIn profile. You guys can feel free to follow or connect with me. You are welcome to reach out if you have any questions related to SACCR, SACVA, or market risk related topics, or even any questions on a programming in C++ or Python. I'm also happy to collaborate, discuss on these topics. Let's get started. This is the code I have written. I developed in PyQt. It's running. So in the meanwhile, let's see what is the definition of SACCR and what it says. SACCR, like I mentioned, it stands for Standard Approach for Counterparty Credit Risk. It is a regulatory framework developed by BCBS. BCBS means Basel Committee on Banking Supervision, which measures the counterparty credit risk of derivative transaction. The main objective of SACCR to figure out exposure at default. If you see, this tool contains the several tabs. First tab, exposure at default with no ISDA and no CSA calculation. And second tab, EAD calculations with ISDA and no CSA calculation. Third tab, it contains the both EAD with ISDA and CSA calculation. Third one is fourth tab is a risk weight tab, and final tab is the data load tab. Data load tab is the entry point for this application. I'll come back to this. Uh, Before that, I want to just walk you through risk weight tab. Here in risk weight, we have a maturity table, supervisory factor table, parameters, and maturity factor table. These are all static parameter that we use in the calculation of SACCR. So my idea is like, if in future BCBS comes with the new parameter values, then we can simply come to this tab and change these values. So EAD calculator will pick it up all these value automatically. Instead of we go and change into a specific place, we can update it here. That is the idea. Suppose if you want to update the alpha value as a 2, we can change it and we can simply click on update parameters, then it will update automatically. That's the idea. So let's go back to the data load profile, tab. And also let me explain why we are, what is ISDA and CSA. ISDA is full form International Swaps and Derivative Association. CSA full form Credit Support Annexure. ISDA is primarily using for the netting purpose. CSA majorly using for the collateral purpose. So by using these agreements, we can create a comprehensive framework for managing counterparty risk in derivative transactions. I'm loading the, for calculation purpose, I created some dummy data. I'm loading that dummy data here. Once we load the file, we can see the pop-up, and also it changes the color. Currently, I have not included, database connections or some other features into this tool. My idea is like to show you the calculations, how it is happening and how this tool is coming up with the EAD. But in future, or if anyone needs, then I can also add, like I can connect this tool to the database. I can add those features also to this tool. And also, since I'm targeting to calculate the EAD, I haven't incorporated or included, visualization also. These are the two are pending items. I'll do that later. If anyone needs, then I can provide those functionalities as well. And one another part, once we load the data, then we can see the different columns like trade ID, asset, product ID, etc. And the important columns are like netting and collateral. These two columns make differentiate and how to load the data into these three tabs. Like I mentioned before, EAD no is the CSA calculation. If we come to this tab and subdata, all columns which are flagged as a false for netting and collateral comes under this tab. EAD no is the CSA calculation. That's what you can see it here. And EAD is the, and if you go to the sub data, here the data is a bit different. Here the data is loading with netting, only netting flag as a true. And the third tab, subdata, if you see, here the data is loading for all trades which are netting and collateral are flagging as a true. Okay. Once we load the data, this is the first step point, right? Then my tool automatically calculates replication cost, potential future exposure. SACCR majorly calculates the EAD, exposure at default, right? So EAD formula itself alpha into replication cost plus potential future exposure. So it calculates replication cost. Replication cost we can, you know, calculate in two ways for margined and unmargined trades. Uh, Simply like margin trades are transaction where collateral is posted. Unmargined trades are transactions are where collateral is not posted. So EAD no ISDA is a unmargined transaction. EAD ISDA also unmargined transaction. That's what you can see on the top of uh, the label. Here I mentioned as an OISDA CSA. And if you go to the third tab, here you can see the margin. So there is a small difference to calculate a replication cost. For margin, we use the formula, maximum of V minus C, where V is the MTM calculation and C is the collateral. Since collateral is a zero, we always get the maximum value of MTM comma 0. If it is a negative MTM, then it takes the zero value. That's what you can see here. For the negative values, it is taking is zero replication cost. So replication cost means it is the true cost for a bank. Like if counterparty defaults, this is the amount that we are going to lose. That is what replication cost is. Generally, it is in a positive only. It means it is a favor to the bank. If it is in a negative, it is not favor to the bank. So once we calculate the replication cost, then we have to calculate adjusted notional. So in the process of calculating potential future exposure, we have to take the consider of netting and delta adjustment, maturity factor adjustment, and supervisory parameters. So these are all values like I mentioned before. I loaded it here. Suppose supervisory factor, what is the correlation and what is the supervisory factor rate that we have to take for different asset classes like interest rate, FXT, credit derivatives, commodities, etc. These are all values are I updated here. These values suggested by BCBS only. So uh, in the process of calculating the PFE, first we have to calculate the adjusted notional, effective notional, and finally add on. This is the uh, total add-on is the potential future exposure. I'm not taking you through the step-by-step calculation. Maybe I can record another video, to calculate how I'm coming up with each calculation, but I just uh, walk you through high level, and my uh, intention want to show you how the EAD is appearing in this tool. So adjusted notional is a standardized measure of size of a derivative trade, and the name itself saying it adjusted to specific characters of trade, such as time to maturity, current rates, and market rates. So if you see a few of the places, it calculates trade level, and few of the places it calculates at asset level. If you ask me shortly whether EAD or SACCR calculates at portfolio level or a counterparty level, I can say that SACCR calculated at counterparty level for netting, and however the calculations are aggregated across all netting sets to determine the total EAD. That's what I can say. So if you see all the calculations happening here at a trade level, and second one is the adjusted notional calculations happening at asset level. Even I mentioned here as a different column what type of calculation am I applying to the each asset class. So for interest rate derivatives and credit rate derivatives, I'm applying, time-based calculation approach. Time-based calculation approach where, adjusted notional account for the time value of money using discounted formula uh, based on start and end dates. Maybe, I can just show you how I doing this in adjusted notional data. This is the one function I'm using for asset class like interest rate derivatives and credit rate derivatives. I'm using the calculated adjusted. See, this is what I was referring to, where it has some discounted formulas based on start and end dates. So start date is this is the formula I used, and end date is the formula I used. And finally, I calculated discounted interest using this formula. So for each asset class, I followed certain formulas at this stage for adjusted notional calculation. So for equity derivatives and commodity derivatives, I use the formula for units and prices, where adjusted notional is the product of the numbers of unit and the spot price. Price means spot price. So by multiplying that, then we are going to get the adjusted notional for that entire asset class. So once we come up with this number, then we calculate effective notional calculations. This effective notional calculation used in the calculation of PFE. For this also, I have implemented a couple of functions. Like I mentioned, I'm going to record another detailed video that how I'm calculating for each asset class, how I'm calculating manually. Maybe I can explain you with a couple of examples in another video. So notional account, it accounts for additional risk factors such as trade direction, maturity, netting uh, within the specific groups. Okay, once we calculate the effective notional calculation, then we are going to get the total effective notional calculation. Even though we are not using the simply total effective notional calculation and add-on calculation, I just want to show you the how each tab, like effective notional or adjusted notional, the total value, and below to that tab or the group. So add-on calculator is the process of computing the uh, potential future exposure for netting set of derivative trades. So once we calculate for each asset class add-on calculation, it it provide you the total add-on. That is what like we discussed earlier. EAD is simply alpha into replication cost plus potential future exposure, right? If you see here, that is what. And apart from that, I also try to populate a few more columns like total V, which is a total MTM and a total collateral for this entire portfolio, and the total add-on. This is the simply number that we got it from the add-on calculator. So EAD is the alpha into replication cost plus potential future exposure. Once this number populated here, it automatically calculates the EAD. So this EAD basically SACCR calculates for the several reasons, but major two reasons are like Basel III come up with this SACCR framework, and it replacing the older Basel II methods like CEM, current exposure method, and standardized method in Basel II, because it enhanced the bank's risk calculations. And also the major reason is like uh, it considers factors like notional amount, market condition, netting agreements, and compared to the older method, it better captures the risk profile. This is the one reason. And another reason, Basel III mandates all banks to calculate SSCCR, whether they want to understand all the banks are holding the sufficient capital to cover potential losses from their counterparty defaults. So these are the two major reasons they calculate the EAD. Uh, so that's how we finally arrive with the EAD calculation. The same process can take place for even EAD with ISDA, EAD with ISDA, and CSA calculation. So like I mentioned, this tool definitely helpful for banks to calculate EAD by sharing certain columns or details. So since this is the first version only, so I haven't incorporated connecting to the databases. Maybe I can do it in the next version. Thank you, guys.